Welcome to this presentation. We are Group 31 and we will be presenting what was done for this assignment. These are our group members and our respective roles. In this assignment, we work with employee reviews from Glassdoor, focusing on the IT industry. We crawl through the website, perform indexing, and train models for sentiment analysis, including exploring aspect-based sentiment analysis. The end product is a simple UI, enabling users to query relevant reviews. Geospatial and timeline search options were implemented to enhance the search results. Our goal is to help job seekers gain deeper insights into employees' feedback to aid their job search.
For crawling, we utilize Selenium and undetected Chroma libraries to programmatically mimic human browsing behavior and bypass Cloudflare's anti-scraping measures to get hold of data. We initially perform a first-level crawl to get a list of tech companies that have job listings in Singapore. We then perform a second-level crawl to get reviews for each of the crawled companies, scraping for essential information such as its overall rating and the pros and cons of the company. In total, we compile data from across 200 companies, averaging around 100 reviews per company, which amounts to a total of over 20,000 reviews, comprising of over 1.2 million words and close to 34,000 unique words.
Our pre-processing includes data inconsistency detection followed by cleaning and normalization using regex and emoji and clean text libraries. Here's an example. For indexing, we tried various approaches, including manually implementing our own system, consisting of an encoder and an indexer, to be explained in the next slide. Let's go through the encoders first. We have a TF-IDF encoder that works well for queries containing terms seen in the corpus. Unfortunately, it does not retain semantic information. On the other hand, the sentence transformer encoder does retain semantic information using a pre-trained LLM at the cost of some added complexity. For the indexers, we have the brute force indexer, which simply stores and searches the encoded data naively upon receiving a query. This is in contrast to the lead indexer that aims to reduce the number of computations performed per query, thus increasing scalability to larger datasets.
Additionally, we also implemented Elasticsearch for indexing. Elasticsearch uses inverse indexing VM25, which is also TF-IDF based. We chose to use analyzers to tokenize our text to lower cases and remove English stop words that can be unnecessary to our index retrieval system. To retrieve our index documents, we utilize queries defined using JSON-based query domain-specific language, which supports simple keyword searches to complex Boolean expressions with filters and aggregations. Finally, we dockerize our indexing stack for ease of use and deployment across different environments.
Before performing polarity classification for sentiment analysis, we conducted subjectivity analysis to identify neutral and objective reviews. We found that most reviews were opinionated, with few being objective. To prepare the evaluation data, we had at least 2 annotators for labeling to reduce errors and conflicts. The final unlabeled evaluation dataset obtained is relatively balanced. For polarity classification, we explored Veda, a rule-based sentiment analysis tool, and Berg, a machine learning approach which has a transformer-based architecture. For Veda, we applied the pre-trained model, which uses a social media text lexicon. For Distilled, we used a subset of a company reviews dataset from a Kaggle community prediction competition with 36,000 reviews for training. The polarity split is even. For innovation, we explored aspect-based sentiment analysis, a fine-grained classification task involving 2 main stages, extracting aspect terms and assigning polarity to each aspect. We aggregated aspect-level sentiments to determine the overall sentiment for each review by merging polarity probabilities. The polarity with the highest score is taken as its overall polarity. Comparing the 3 different approaches, we found Distilled performed the best, partly because it was fine-tuned. Interestingly, the recall is higher than the precision for all models, which suggests a larger proportion of false positives as compared to false negatives. This could be because there are generally more positive reviews, and even within a negative review, positive words are being used in a negative or sarcastic way.
The basic functions of the UI include a basic search engine with filters, and we also explored geospatial and timeline search capabilities, as well as providing users with enhanced results through visualizations and aspect-based sentiments. Here is our UI. Suppose I'm interested in high compensation, bonuses, and also a high workload, and I also like a software engineer role at these few firms. I can then view the distribution of review sentiments as well as overall rating. Read reviews displayed in pages of 5 cards ordered by relevance. And aspects detected within the text can also be color labeled based on their polarity.
We also have a spell correction feature where misspelled words are detected and the corrected suggestions are made known to the user. Filtering can also be done on the location which the job was based in by selecting directly from the geospatial plot. Finally, I can also select my desired date range for the timeline search.
In conclusion, through the 3 stages, crawling, indexing, and querying, and classification, we perform sentiment analysis on Glassdoor reviews. We hope users can make informed career decisions through our UI, which is supported by our innovations. Thank you, and we hope you enjoyed the presentation.